Paper 1R, June 2016, question 8. So a question about electrical appliances, power and current in the table at the top, 3 examples of appliances, lamp, iron and television. Question A1 says, state the relationship between power, current and voltage. So we're thinking about PIV here, which in words is power equals current times voltage. Write it out in words. Calculate the current in the television. And we're assuming that mains voltage is 230 volts. So they're not expecting you to know that. So you need to rearrange the equation. So current equals, so it's going to be power divided by voltage. So you don't get marks just for that, but you do get marks for putting the numbers in the right place. So the power you're getting from the table at the top here, so it's 110. The voltage you're getting from the question, 230. So the answer is 0.48. And I've already given you the unit, which is amps. Part B. Photographs show the different cables used for the clothes iron and for the lamp. And you'll notice that there's a couple of differences. So the iron cable has 3 wires, the lamp cable only has 2. But the first question asks, suggest why the wires in the iron cable are thicker than the wires in the lamp cable. So the easiest and hopefully the most obvious answer is just that for the clothes iron, there is a higher current flowing through the wires, so they need to be thicker. The reason for that is because a thicker wire will have a lower resistance, but this is only for 1 mark and it's only a suggest, so we don't need to go into that much detail. If you do, that's fine, but the mark, you can get the mark just for saying higher current in the iron. The iron's cable. So the clothes iron cable has 3 wires, E, N and L. Hopefully you've realised what they stand for. So E stands for earth, N stands for neutral, and L stands for live. And you should remember from your practicing putting the plugs together that the fuse is always connected to the live wire. So that's the answer to that question. But for the lamp cable, we look back at the picture, that has only 2 wires. So when things only have 2 wires, or only 2 pins in the plug, then the wire that's missing is always the earth wire. As we know, that's just for safety. That doesn't take any part in actually transmitting current or energy when the appliance is working safely. So suggest why the lamp is safe to use, even though it only has 2 wires. So even though it doesn't have an earth wire. And the reason for that is, well, the best reason is that the lamp has no exposed metal parts, that its case is completely made of plastic. That's the one I would go for. So no exposed metal parts, or the case made of plastic, no metal. A second point that you could make is that the cable is double insulated, or the lamp is double insulated. So for part C, maths question, 3 marks. The lamp is switched on for 55 minutes. Calculate the energy transferred by the lamp in this time. So we were given earlier the equation power equals current times voltage. We haven't really used that yet, so there's a clue there. But we want energy. So looking at everything else that you have in the question, we've got this information up at the top, which we've, again, not used yet. So there should be a clue there. So calculate the energy transferred by the lamp in this time. So let's look back at the information we have for the lamp. So we have that the power is 40 watts and the current is 0.17 amps. So let's just write this down here, remind ourselves, 0.17 amps. So we've got current, we've got power, we've got time, and we need energy. What would be the other thing that we would need? So we've got two equations that link power. So the first one is we've got power multiplied by time. And then we've got the equation that we were asked for earlier, which is current times voltage. And it's a really common question to put those two equations together, to have a question that uses both of those. So if you put them both together, if you're feeling mathematical that way, you will end up with I, V, and T. So we've got current, we've got the voltage from earlier, which is 230 volts. I'll write that down, it runs on the mains. And we also have time, but just as an extra level, we've got to turn it into time in seconds. So we've got to do 55 multiplied by 60 because your time needs to be in seconds. So putting that all together, we end up with 0.17 times by 230 times by 55 times by 60. There. And that would give you the answer 130,000 joules. Now, some of you should probably have realised that I've made that far more difficult than it needed to be. It's the right answer, but you were also given the 40 watts, which is the power. So we could just use this one. So you can just see sometimes even physics teachers make mistakes, although I still got the right answer. So if you don't want to go through that whole rigmarole, what you can do is just do 40 multiplied by 55 multiplied by 60. And you'll end up with the same answer a lot more easily. Make sure you've got joules because we need the unit.